Okay, and hello to the next video in this statistics series. We're going to be looking at hypothesis testing for zero correlation, and we're going to be using the knowledge from the PMCC video to help us, and obviously our knowledge from hypothesis testing in year 12 to get through this theory. Okay, so what is hypothesis testing all about? Well, in essence, we all remember from year 12 we have a null hypothesis H0, which is what we assume to be true, and we test it against an alternative hypothesis H1 at a certain significance level. It could be 1%, could be 5%, whatever. And there's normally a strict sort of template to doing this, and a lot of the times with hypothesis testing at A level, as long as you're comfortable with the template and you can obviously execute a one-tailed test properly or two-tailed test properly and give a good conclusion, then you'll get all the marks. Okay, so in this context of correlation, what is hypothesis testing all about? So if you remember the PMCC video, I talked about this concept of measuring correlation, and I showed you on your calculator how to do it. And one aspect of this involved, looking at that value of R and thinking, what does that tell me about the correlation between two variables? So what hypothesis testing is all about is we've got a situation where we've got R, and that represents the correlation between two variables of a sample. And what we're going to try and ascertain or determine is whether is that value of R good enough for us to use as a population to sort of estimate for the population PMCC. Is it, with the significance level, is it significant enough to be used as an estimate for the population PMCC? And the symbol for the population PMCC is this weird looking P, which is actually a symbol that we're using, and it's actually called rho. Okay, RHO, say it like that. So again, let's just try and identify what we're doing here. We're going to use R, and we're going to try and see, is it a good estimator for the population? Okay, now the method for this and for most hypothesis testing, they're slightly different in their own way in the A-level course, but there's always the basics. So we're going to go through the workbook pages dealing with this. Okay, so you can use a hypothesis test to determine whether the PMCC for a sample indicates there's likely to be a linear relationship within the whole population. Remember in the PMCC video, guys, if there is a good strong positive relationship, the value of R is close to 1, or if the value of R is close to -1, that would indicate a linear relationship. Okay, we can also use hypothesis testing given a sample and the PMCC R to test whether the PMCC for population is 0. So we've got 3 possible scenarios here, and guys, you've got to read the question, and once you've understood what scenario it is, you've got to start off writing your hypotheses. So if we are testing for positive correlation, we would write H0, rho is equal to 0, and the alternative is that rho is greater than 0. If we're testing for negative correlation, we write H0, that rho is equal to 0, and the alternative rho is less than 0. And if it's a two-tailed test, then obviously we'd test whether rho is equal to 0 or rho is not equal to 0. Okay, and you've got to be able to determine which one it is. Now, in the formula books, there is a table that we're going to use, and it looks like this. So page 37 of the formula book has this table. You do not need to look at Spearman's coefficient, and this is the boundary of the table that we're interested in. Now, this table, as I said, is in page 37 of the formula book, but it's also on page 191 of the Year 2 textbook, so you can access this from the Year 2 textbook. So how do we use this table? Well, what we're going to do, guys, is we're going to look at a sample size we're going to be ascertaining, and we're going to read across and down. So we're going to read across from the sample size given to us in the question, and we're then going to go down the significance level that we've got here. Okay, now clearly this is 10%, 5%, 2.5%, 1%, 0.5%. Okay, and we're just going to read across and read down, and once we get to that stage, what we'll get is a critical value. Okay, and that critical value will help us in terms of answering the question. Once we have a critical value, we look at our hypotheses, and then we compare it to our value of R, and then we see if it's significant enough for the population product moment correlation coefficient. Okay, so I'm going to bring this question, which is from the workbook here. So a sample of 20 footballers was taken. That's really important. And their age and time taken to run 100 meters recorded. So the two variables are age and time. A PMCC correlation was taken, was calculated, and the value was 0.489. Okay. Test whether or not this shows evidence of correlation at the 5% level or at the 2% level. So let's just try and understand this. The value of R for the sample was 0.489. Now that would indicate a fairly positive correlation between age and time taken to run, which would make sense in the real world in terms of age of an individual and the capacity to run 100 meters. Okay, but we've got to think, is that, according to the significance levels, is it showing evidence of correlation? Would it show evidence of correlation for a population? So this is what we'll do then. R is 0.489, and part A says test this at 5% significance level. So before we do that, let's just write the hypotheses. So the null hypothesis is that the population PMCC is equal to 0. The alternative hypothesis comes from you reading the question. Test whether or not this shows evidence at that level. Okay, so evidence of correlation. Now, in this particular question, we've got to understand, what do we think they're going to be asking us to do? And I think in this situation, they're going to be asking us to say, is it showing evidence of a positive correlation at a significance level? So we're going to say the alternative hypothesis is that rho is greater than 0. Now obviously, as I said, we write the significance level, 5% level. Okay, and the sample size is 20. So what I'd do, I'd look at my table, and I'd read either down or across and down, it's up to you. And I go, okay, 0.05, okay, that's 5%, and 20. So I'll see where they join up, and they seem to join up here. Okay, 0.3783. So the critical value is 0.3783. So what do we do now? Well, what we've got to understand is correlation, and strictly in the sense of mathematical language that we've been using for PMCC. The value of correlation is between -1 and 1. And 0.3783, that is here. Okay. And critical value is basically the value of the correlation coefficient, which has a probability which is less than 5%. Now, in terms of the critical region, this is the most important thing, guys. We do need to get critical region, and the critical region depends on the question. So if you're looking for greater than 0, if you're looking for a positive correlation, the critical region will be everything greater than 0.3783. Okay, so what we're looking at is here 0.3783, and any value of R which lies in that critical region, we would have to then reject the null hypothesis. And I'm sure you guys should remember this from year 12 hypothesis testing. Critical region is the region of values that are so low, the probabilities of them are so low, that if your test statistic, which is what this is the test statistic, is the statistical bit of data from doing a test. If that is in the region, then we'll say at this level there is sufficient evidence to reject the null hypothesis. So 0.3783, the critical region is everything to the right of it, and our test statistic is 0.489. So 0.489, that is greater than 0.3783. So therefore, at the 5% level, significance level, there is sufficient evidence to reject the null hypothesis. Okay, and you also have to give your conclusion in context. So you'd also have to say that there is evidence to suggest a positive correlation between age and time taken to run 100 meters. Okay, so that's fine. That's basically it. So again, let's just recap. You have to set the scene with your hypotheses here. You understand what your significance level is and your sample size. You get the critical value from reading across and down. You then establish where your critical region is depending on the question, and then you think about your test statistic and is that in the critical region or not. Okay, so that's part A, which is at a 5% level. What happens in part B, a 2% level? Well, at 2% level, I'm going to keep the same hypotheses, the sample size is still the same, and let's see what happens now. The critical value, I'm just going to write CV. The critical value when I look at 2%, oh, it doesn't seem to be there. I'll change it to 1%, just to make sure we can get it. So 1%, I'll just change the question, and again at 20, 1%, I'm just going to read down 1%, sample size of 20, and we get to this critical value here, 0.5155. Okay, and what you should notice now is, if I was to do another line again, the critical value 0.5155, and therefore its critical region, which is everything to the right of it, because we're still doing a one-tailed test. One-tailed, if you remember from year 12, testing one end of the probability scale. So the critical region is everything to the right of 0.5155. Our critical value, our test statistic, however, 0.489 is now not in the critical region. It's outside of it, just outside of it. So 0.489 is less than 0.5155, and that makes sense in a way, because when you drop the significance level, it basically means that the probabilities have to get lower and lower and lower for you to accept the alternative hypothesis. So at 5%, that was fine. We accepted the alternative hypothesis. At 1%, I've increased the criteria, the difficulty now. It's not passing it now. Okay, so at 1% level, there is insufficient evidence to reject H naught. Okay, and obviously you'd write in terms of context. In other words, not enough evidence to suggest a positive correlation between age and 100 meter running. Okay. The language of hypothesis testing when it comes to writing conclusions is not, you don't commit to anything. It's very much like evidence to suggest, not insufficient evidence to suggest. It's not like, yeah, definitely there is correlation, definitely there's not. Okay, you have to keep that in mind. Okay, so that's an example of a one-tailed test. Okay, so in the previous video, I showed you how to do hypothesis testing for zero correlation, and the example that we worked through from the workbook was a one-tailed test. So we were looking at positive correlation, and obviously I'm sure you guys can all sort of imagine, if you're to do negative correlation, or if you're testing for negative correlation, once you get your critical value, and if you're testing for negative correlation, your critical region will be everything less than that critical value. However, what would happen if you're doing a two-tailed test, and how would you deal with that? Well, there's you have to sort of consider that as well, and make sure you don't sort of get confused with the one-tailed aspect. So I've just taken this example from the textbook. It's example 3 from this section, hypothesis testing, in the year 2 textbook. I printed it out. So we've got a scientist. He's taken 30 observations of the masses of 2 reactants in an experiment. She calculates a PMCC of minus 0.45. Okay. The scientist believes that there is no correlation between the masses of the 2 reactants. Okay. Test at the 10% level of significance. The scientists claim, stating your hypothesis clearly. So first of all, let's analyze the hypothesis. The null hypothesis is always rho is equal to 0, the population PMCC is equal to 0. Remember, the test statistic is what the scientist has calculated. The alternate hypothesis, however, is going to be that. Okay, so you need to test for either positive or negative, so we're going to use a two-tailed test here. Okay, so we're going to test at a 10% level, and if you guys remember, you should remember from year 12, when you test at 10% level for a two-tailed test, what that actually means is you're going to test at a 5% level in each tail. Okay, so that will make things a bit different in your working. The sample size is 30. Now obviously guys, this section of the table in the workbook does not go up to 30. In the sample size it only goes to 20. So the formula book does do it. You can also find that formula book on the internet, but I'm going to just cut to the chase and just get to the critical value. So again, if you had that in front of you, you'd go down to 30, go to 5%, and what you'd get is a critical value for R, which is 0.3061. Now, the main difference here when you're doing a two-tailed test is because you're looking at positive or negative, you also have to incorporate that in as part of the critical value. Okay, so the critical value could be positive 0.30161 or minus 0.3061. Now, obviously, because we're testing upper and lower, 0 is here, minus 1 is here, 1 is here, minus 0.3061 and plus 0.3061. And the upper tail would be everything to the right here, and the lower tail will be everything to the left here. Okay, so if our test statistic lies in either this critical region or this critical region, we can reject the null hypothesis. Okay, so we've got our critical regions there, and once we've analysed that, then we think minus 0.45. Minus 0.45, which is the test statistic, that is in here, in the lower critical region. Okay, so what that basically means is minus 0.45 is less than minus 0.3061, and therefore you would reject H0. And obviously you have to come up with your conclusion statement. Okay, so you'd say at the 10% level, there is sufficient evidence to suggest a correlation between the two masses. Okay, so that's how we do a two-tailed test with regards to this particular hypothesis testing topic. So the questions I'd like you to do now relate to page 10, exercise 1C, and the questions from question 1, and see if you can finish the exercise. I mean, a lot of these questions aren't that difficult because actually you're just calculating the PMCC, and that doesn't take too much time using a calculator. So questions 1 to 10, and that should be it really for this topic. Thank you very much, and I'll leave it there.